takes us to get through the material. But P1, you're supposed to be working on your homework as we go, and you can finish P1 next week, done.
It's on the book, right?
Yep. Oh, I think there's one more sheet, but I haven't given to you yet.
All right.
Like P5 or something else. All right, here we go. So we are now on page 2 of our notes. Section P2. You've done all this stuff before. So we got some things to label. Anybody know what we call this setup here? This setup has a name. What do we call this setup? Lauren? Well, it certainly is a graph. It is, absolutely. It's called the Cartesian coordinate plane. The Cartesian coordinate plane. Rene Descartes, one of the greatest mathematicians of all time. Great mathematician and philosopher, Rene Descartes. Okay, I've kind of given it away. This thing's called the what? What do we call this? That's the x-axis. This one is the y-axis. Okay, so we can label those. What do we call this point right here in the center? That's called the origin. Yep, that's called the origin. And then when you draw in your x and y axes here, you're like splitting the plane up into 4 pieces, right? Those 4 pieces are called quadrants. And the quadrants are labeled the same way by people all over the world. Everybody labels the quadrants. This one is 1, 2, 3, 4. And we generally use Roman numerals to identify the quadrants. Not sure why, but that's just how we do it. So if you're talking to your friend on the phone and you want to talk about quadrant 3, everybody knows this is what you're talking about, right? Number 2. Everybody good with all your labels there? All right, number 2. You got a couple of points, and you're supposed to figure out what this means. Does anybody know what that notation means? Well, it says AB. What does it mean, Lauren? Well, the 2 points won't meet. What it means is how far apart they are. So this means the distance from A to B. That's the notation that means distance. Now, you all have done distance between points before. Does anyone remember how that works? How we do that? David?
Is it the x1 minus, or y1 minus y2 over x1 minus x2?
That is something really, really important that we're going to talk about here shortly. That's called what? That's slope. That's slope. So you're in the right ballpark. I mean, you're in the right area. We just have not quite the right formula. The distance, remember, is the one that has the big radical. It's not the quadratic formula. That's something else that we'll also talk about in this chapter. But the distance formula says you take your x's and you subtract them and square that. And then you take your y's and subtract them and square that. Uh-oh. And then we add those 2 things together and take the square root. Now that better look familiar to you because you did it in first year algebra, geometry, and second year algebra. You've seen that before. So for our problem, and oh, by the way, no one is ever going to ask you to write the distance formula. So if all those letters and things confuse you, it's fine. Just know how it works. You don't have to write the formula. You just have to know how it works. So this tells me to take my x's, these are my x's, and subtract them. So 7 minus negative 1. And I'm going to square that. So I got to do my arithmetic carefully. 7 minus negative 1. And then square that. So everybody see how I did that? X minus x squared, y minus y squared. All right, let's get those brains working. What's 7 minus negative 1? 8 squared.
64.
Perfect. 1 minus 3? Negative 2 squared. 4. Remember, when you square it, it's always going to be positive. So we have the square root of 68. Now, you've all been down this road before. You have to reduce that if it reduces. So we have to figure out if 68 breaks down. I know it's not a perfect square, but does it break down at all? Well, Huffines over here saying, yeah, it breaks down. How?
You gotta go 34 times 2. You know,
Okay,
factor it
so
out.
he's saying I gotta do this kind of thing. So 2 times 34,
And then 17.
and then 2 times 17.
Then you circle it 2 2s.
And
Two
since there are 2 2's, we can bring them out.
Yeah.
So we're going to have a 2 on the outside and a 17 on the inside. Whatever you have 2 of gets to come out. Everything else stays inside. So the answer to the question is 2 root 17. All right, let's go through B together, and then you can do a couple on your own. So B, we're finding the distance between 2 6 and negative 5 1. So next quiz we have, this will be a question, and you gotta know that notation, AB. When you see AB sitting there, that means find the distance. I'm not gonna tell you that. It's not gonna say find the distance. You're not gonna come up and ask me. You're going to know that means find the distance. All right, so here we go. Here's my radical. So I got 2 minus negative 5. I'm going to square that. And I got 6 minus 1, and I'm going to square that. Now, nobody's bothered by the order of my subtraction, right? It doesn't matter what order I subtract. If you would rather do negative 5 minus 2, that's okay. You're going to square it, so it doesn't matter. 2 minus negative 5, 6 minus 1. So, what is 2 minus negative 5?
7.
7 squared, 49. 6 minus 1
5.
squared.
25.
So this one comes out to be the square root of 74. Shepherd's is back there kind of nodding his head. Or shaking his head. Doesn't break down.
37.
Because it's 2 times 37. So therefore, what's our answer? Square root of 74. Can't break it down. You only have 1, 2, and 1, 37. What? You can do that right after school? It won't take very long, 5 minutes probably. All right, C. Would you try C on your own, please? You can do this. Lots of negatives floating around. Be careful with those things. Remember, our distance formula is x minus x squared, y minus y squared. X minus x, y minus y. Square them both, add them up, take the square root. What did you get here? When you did negative 8 minus negative 5?
I didn't add another negative.
you get here?
3.
3 squared is
9.
9.
Oh, okay, I did it right now.
And 4 minus 2 squared.
1.
Did you get root 13?
Yep.
That's the right answer.
Okay.
That's the right answer. Okay? Now look at number 3. We are finding the midpoint. You've done this before too. How do we find midpoint?
Would you multiply?
We don't multiply. Not when we find midpoint.
Or add?
We definitely add. I want you to think about something for a minute. If you took a test and got a 90, and you took another test and got an 80, how would I find your grade, your middle grade? How would I do that? If you had a 90 and an 80, what would I do? Add them and divide by 2. Isn't that how we find a middle value? We add and divide by 2. So to find a midpoint, I am just going to add my x's together. So -1 plus 6. I add my x's. I want to find the middle x, the midpoint x, the middle x. So I add them and divide by 2. So I got 5 halves. You might say 2.5 or 2.5. That's fine. How do I find a midpoint? I average. I add and divide by 2. So what's my middle y? 2 plus 4 divided by 2. So my midpoint y, my middle y is 3. And there it is. There is your midpoint. How do we find midpoint? We add and divide by 2. In other words, we average. We average. So what's the midpoint for number 3? Or letter B, I'm sorry, letter B. We have -7.2 and 0.5. What will our midpoint be? Add your x's and divide by 2. So what do we get when we add our x's? -7/2, that's it, period. Don't make it hard, oh my gosh, it's easy. You add your x's, divide by 2. Now let's add our y's. What do we get when we add our y's? 7/2. Midpoint is average. Midpoint is average. You add and divide by 2. Now, keep that thought in the back of your mind. We're going to need that in just a minute. But first, we're going to look at these equations here that look really scary, but they're not. They're very, very simple. These are circles. These are equations of circles. You've seen these before, only last year. Can you tell me the center and the radius of this circle? Anybody want to take a wild guess?
4.
The radius is 4. The radius is 4. Absolutely. What's the center? 0, 0. The center is at the origin, and the radius is 4. Now I see some dazed looks out there. So I'm going to jump down here to this one. The center of this one is 2, -3. The center of this circle is 2, -3. So in other words, the center is the opposite of what's inside the parentheses. Now back up to this one. There aren't any parentheses, right? So does it make sense to you that since there are no numbers up there, the center would be at 0, 0?
Yeah.
If there are numbers, the center is the opposite of the parentheses. Now the radius of this one, as Huffine said, the radius of this one was 4. because the square root of 16 is 4. And to find the radius, we just square root that number. So what's the radius of this one? Not 15, the square root of 15. To find the radius, you square root that number. So that's how we got 4 for the radius. All right? That might be a little bit new, so make sure you took good notes in the margins. How do we find the center? We take the opposite of the parentheses. What if there's no parentheses? Then it's just 0. How do we find our radius? We take the square root of that number, right? The equals number. Now, let's see if you're paying attention. The center is 1, 4, and the radius is 6. Could you write the equation? Could you write this right here?
Yes.
What would that look like if that's the center and that's the radius?
X minus 1.
X minus 1
Plus
squared,
y
don't forget the squared, plus y minus 4 squared equals 36. You're just doing it backwards. The opposite is the center. The square root of that is the radius. How about the last one?
X plus 3
X
squared.
plus 3 squared, perfect.
Plus y minus 2 squared.
Y minus 2 squared, perfect.
Equals 100.
Equals 100. Magnificent. Everybody good? Because now I'm going to whammy you. Now we're going to write the equation of the circle. So you're going to do exactly what you just did. This is the equation of the circle, right there. But all I'm going to tell you is that it has a diameter, and you remember what a diameter is, with endpoints at -1, 5, and 3, 7. So this is all you have, and this is what you want to come up with. So you want to come up with the equation of a circle just like you did right there, but that's all you've got. Mr. Stewart. Do you hear what he said? To write the equation of the circle, you need to know what the center is, right? If you know the center, can't you fill all this in? And he said the center will be the midpoint of these 2 points. All right, and how do we find midpoint? We average. So here we go. What is -1 plus 3? 2 divided by 2. 1. Don't forget, when you average, you're adding and dividing by 2. All right, so 5 and 7 makes 12. Divided by 2 is 6. Remember, midpoint is average. Average. Add, divide by 2. Average. So when you're writing your equation, won't this be x minus 1 squared and y minus 6 squared? Now to get this number, we need to know the radius. How will I find the radius, do you think? Isn't that the radius right there? So I need to know how far it is from here to here. And to find that distance, I use my distance formula, which tells me to subtract the x's and square them, subtract the y's and square them. Remember, that's how we find distance. X minus x squared, y minus y squared, add them up and square root them. So what have we got? 3 minus 1
2,
squared,
4, plus
7 minus 6
is 1.
squared is 1. So root 5. So this distance is the square root of 5. So what goes up here? 10? What'd you say, David? Okay, what is the square root of 25? 5. Yep, that's what goes here is 5.
Oh, it's only
Because
half.
remember, you take your radius and square it. So what happens when we take root 5 and square it? Remember, when you square a radical, these cancel, so you just end up with 5. Or longhand, like David said, the square root of 25, but the square root of 25 is just plain 5. That's wild and wacky. Right? We'll try another one of those at the end of the period. That's a GTQ, guaranteed test question. So we'll practice another one. But first, let's move on to number 6. Before I erase all this, big ideas. Gotta know how to find distance. How do you find distance? X minus x squared. Y minus y squared. Add them up and square root. How do we find midpoint? Add them and divide by 2. When I look at the equation of a circle, the opposite of the parentheses gives me the center, and the square root of that number gives me the radius. All right, part 6. Anybody remember that, or please tell me you remember that. Mr. Stewart? Honey, you walked in late.
I know.
And now you just can't wait till it's over. Yes. Is there a problem? Okay. When it's 5 minutes early, you just go ahead and leave. All right. Anybody remember what this means? These bars here. What do those bars mean? Absolute value. What does absolute value mean? Make it positive. Now, here comes the trick part. Don't make it positive till you figure out what's inside of it. So you don't just make the -3 positive. That's not how it works. You have to add these together. So -3 plus 2 is -1, and then you make it positive. So the answer is 1. Do not make positive the individual pieces. You got to figure out what the whole thing is, and then make it 1. All right, how about the next one? A little bit tricky. Don't be scared. Here we go. What's 4 minus 7? -3, but it's inside absolute value, so it would be 3. What is 3 plus 1? 4. Absolute value is just 4. Now what are we doing with those two numbers? Subtracting them. So the answer to the question is -1. goes positive, you are going to be in deep trouble. These are absolute values, so let's take care of that. Let's forget this for a second. What's the absolute value of 5? 5. What's the absolute value of negative 5? 5. What am I doing with those? Subtracting them, so the answer to the question is 0. See how easy that is when I force myself to slow down? One step at a time. What's this? Absolute value. What's this? Absolute value. Answer to the question? 14.
Okay.
I know you're having more fun than you look like you're having. How do I do this problem? It says, is negative 2 a solution? You got a couple of different options. What do you think? Anybody have a thought, Amuna? Plug it in? Oh, plug it in. If we plug in negative 2, it should give me a 0. Well, let's see if it does. Negative 2 squared. 4. Minus 4 times negative 2. Be careful. What is that?
8.
Positive 8?
Yes.
Yeah, get you 0.
So is it a solution?
Yeah.
Yeah, it's a solution. That's great. That's actually probably the quickest way to do it, but it's not the only way. Do they have a different idea? Okay, so in other words, solve the original and see if one of the answers you get is negative 2. So this does factor, I think. So the answers are 6 and negative 2. So is negative 2 a solution? Yep, that would be another strategy. For most of us, it's going to be easier just to plug in our number. But certainly you can solve the original equation and see if you get that as an answer. All right, number 2. In P3, we're going to talk about linear equations. In P4, we're going to talk about quadratic equations. I think it's P4. One of the next ones, we're going to talk about quadratics. So linear. What makes something a linear equation? What do you think? Anybody have an idea? Are any of these not linear? Can you immediately discount some of them as being not linear?
That second one?
This one right here?
Yeah.
Okay, he's right. What makes this one not linear? Can't have a radical. So if you're going to be linear, you cannot have, well, I shouldn't say no radicals. I should say no x under a radical. So there's our first rule. If you're going to be linear, x cannot be under a radical. You can have radicals in the equation, they just can't be root x's. Can't have an x under a radical. So you are right, not linear. All right? Anybody see anything else there that isn't linear?
I was gonna say
This one here?
Yeah.
No, not linear. Not linear. This one is not linear, and this one is not linear because you can have no x in the denominator. If you are going to be linear, x can't be under a radical, X can't be in the denominator. All right. Anybody see anything else that's not linear? Have fun, go for it. You're looking at it.
F.
Not linear. Why not?
Just the exponent maybe?
Yeah, can't have an exponent bigger than 1, right? So x must be to only first power. So if you have an x squared, an x cubed, an x to the 2/3, if you have any power other than 1, you are not linear. Linear graphs as a line. If you have radicals, if you have denominators, and if you have powers other than 1, you are not going to graph as a line, you're going to graph as something else. So which ones are linear? This one and this one. On your test, and I know it's a long way away, but I'm going to ask you a question. I'm going to say, is this thing linear? Why or why not? What are you going to check for? Do I have x in the denominator? Do I have x to a power other than 1? And do I have x underneath a radical? Got it? Alright, so we're going to do a few more here, and then we're going to do our review circle problem.
Okay.
You've all solved equations before. So, do I have a volunteer to come up and do problem A? You can do this. This is easy. And then B, a little bit harder, but still easy. And then C. Pretty easy, but might throw you a little bit because of the fractions. Any volunteers that would come up and do these? Aiden, go ahead. Go ahead. Perfect, perfect. Thank you. Here's the marker. What should the rest of you be doing? Exactly what Elliot's doing. He's working away on his equations. Good work, Elliot. Wow. We are equation solving all-stars. How about this one? Do you understand what she did? Got a clue, huh? This one you can do it different ways, but what she said was, I need to get rid of this 2/3 right here, because I ultimately want to have x equals. So I got to get rid of this. So technically, to get rid of it, we would divide by 2/3. But remember, division by 2/3 is the same as multiplying by 3/2. So she did not write all this out. She just said the only way to get rid of that 2/3 is to multiply both sides by 3/2, because then that all goes away. And when we multiply fractions, it's straight across. So she got 12/10, which she magnificently reduced to 6/5. So if we had 5/8x equals 2/3, we could solve that real easily by timesing both sides by what? or 8/5. 8/5.
Oh, you flip it.
You flip it so that they cancel. See how they cancel? So x would equal 16/15. Nicely done. All three of you did a great job. Anybody have a question about these other two? Perfect. All right. Let's do one more circle problem, then we'll be done. You can escape. Let's write the equation of this circle. This is a diameter and his endpoints are 4, 3, and 8, 7. You're going to write the equation of the circle. This is not on the sheet. This is an extra one, so you can squeeze it in the margin or put it on a separate sheet of paper somewhere. Just extra practice, since we know it's going to be a test question. Okay, let's see. Let's gather our thoughts for a minute. Remember, circles look like this. X minus something squared and y minus something squared equals a number. That's what circles look like. So I need to figure out the numbers that go inside here. And those are going to be the center, right? So how am I going to find the center? Midpoint. And how do I find midpoint? I average, right? I add and divide by 2. So 4 and 8 makes 12, divided by 2 is 6. You with me? And then 3 and 7 makes 10, divided by 2 is 5. So the center of the circle is 6, 5. So x minus 6, y minus 5. Now to find this guy, I need to know the radius. And this will be the radius, right? So that means I'll need my distance formula. So how does that work again? 6 minus 8 squared and 5 minus 7 squared.
It'll be the root of 8, which is 4.
No, it's not 4, but you're right. Okay, so 6 minus 8 is 2 squared is 4. 5 minus 7, 2 squared is 4. So my radius is the square root of 8. But remember, when you write your equation, you don't put the radius here, you put the radius squared. So what is the square root of 8 squared? 8. There it is. All right, peeps, great work. You can now finish the P2 assignment too if you want to. Schoology. Schoology. Yep.